Hi everyone, in today's video we will be talking about one of the theorems related to the quadrilaterals, but before stating the theorem and starting to the proof, I just want to talk about convex and concave quadrilaterals. First of all, let's start with concave quadrilaterals. The quadrilateral is a 2D shape which has four different angles and four vertices. As you can see here, we can name them A, B, C, and D. And they can be categorized into two groups, to convex and concave quadrilaterals. And in the picture, actually, you can see the difference, but how we can state this difference? If you just choose two different points in a quadrilateral and just connect them, if we that line that connects these two vertices doesn't intersect with another line, which means that the quadrilateral is convex. For example, let's try A to the C, from B to D, and you see that this line doesn't intersect with any of the sides of this quadrilateral. But in terms of concave quadrilaterals, when we just choose, for example, two sides and try to connect them and drawing one line, you see that this, that's the name again, A dash, B dash, C dash, and D dash. When we connect the vertices D dash and C dash, you see that line that we draw just intersects with the A dash V dash line dash side, and therefore this is called concave quadrilateral. Let's just state the theorem. If our quadrilateral is convex, and for example let's draw one convex quadrilateral, and if the diagonals of this figure just intersects at a right angle, we have a theorem. Actually, I don't know the name of this theorem, and let's just call the sides A, B, C, and D. We can state that the theorem claims that we can state A square plus C square is equal to B square plus D square. But how can we prove this theorem is the challenge of this video. What we will use here will be mainly related to the Pythagorean theorem that we just covered this topic at one of the previous videos. Pythagorean theorem is if the sides of the triangle are right angle triangle are x, y, and z, x square plus y square will give us z square. And this is the Pythagorean theorem. Let's write it here and keep it, or just remembering it. And how to prove it? Let's just call the parts of these diagonals, for example, let's call them x1, x2, y1, and y2. And let's just write the Pythagorean theorem for all the four right-angled triangles we see here. First one, second one, third one, and the fourth. Let's write it. X1 square plus y1 square, 1 square plus y1 square is equal to a square. And let's write it for the side C. X2 square plus y2 square is equal to z square. 2 square plus y2 square is equal to z square. And let's write it for side B. X1 square plus x1 square plus y2 square is equal to b square. And the fourth on the last side, x2 square plus y1 square is equal to d square. And in order to prove the theorem, let's just subtract from the first term the opposing term. Here we wrote, and from this one we should subtract this one and write it with the same order here. When we subtract them, x1s will be cancelled out, and only we will be left with y1 square minus y2 square will be equal to a square minus b square. And here, if we just do the same kind of subtraction, we will get subtraction. We will be left with y2 square minus y1 square, and we will get c square minus d square. And you see the procedure here. Actually, if we multiply this different sides of this equation with -1 and equalize it with the first one, actually we'll get the theorem, proof of our theorem. Let's see. If we multiply with -1, it will be y1 square minus y2 square. This will be equal to this one, and therefore we should just equalize the right hand side of these two equations, 1 and 2. A square minus b square should be equal to, it will be multiplied by -1, therefore it will be d square minus c square. And let's just change the size of these minus terms, negative terms, and we will get a square plus c square, and it should be equal to d square plus b square. Let's compare this final result with our initial theorem and see whether this proof is correct or not. You just keep in mind a square plus c square is equal to d square plus b square. And this is the correct proof actually. And this is the end of our video. I hope that you could learn something beneficial for you. And if you like the video, please comment and subscribe to my YouTube channel. Thank you for watching.